Hello everyone, my name is Laris Soni and you are watching Target Prelims 2026 Revision with MCQ series by Drishti IAS. In this episode, we will be talking about some more questions from the geography section. In the last episode also, we have discussed nearly 10 questions. So if you have not watched that episode, you can go ahead and watch that episode as well. Okay, now let's start with this episode and question number 1. So question number 1 says that consider the following statement regarding the air masses. Now they are talking about air mass. We will be seeing that what this statement says. Statement 1 says that it is a large body of air having uniform temperature and humidity characteristics acquired from a source region. Okay, so there are three things which you have to keep in mind. That is, 1, this is the large body of air. Second is that it is having uniform temperature and humidity conditions that has been acquired from a source. There are three things. 1, that the body of air is large. Second is there is a source, and because of that source they have acquired a few characteristics related to the temperature and humidity. Obviously, we are talking about the air mass. This particular statement is true. For example, see, this is your desert. In the desert surface, if it is a hot desert, for example, hot and dry, if it is a hot and dry desert, so the air mass which is above this, or the air pocket which is above this, tend to have high temperature because it is a hot desert. Because of the convection or other reasons, the temperature of the air will be high. But when we are talking about the dry part or the humidity related part, obviously there is no you can say water or any kind of moisture which is available in the desert. So this particular air mass will be dry. That means that it will be having less humidity, right? So that is what has been said, that because of the source region, they are having a particular characteristics which are uniform in nature throughout the large body of air mass. That is called as air mass, or large body of air pocket, which is called as air mass. So statement 1 is correct. Coming to the second statement, air masses generally form over large uniform surfaces such as ocean, desert or snow covered plains. So if we are talking about the deserts, so there are two kind of desert, hot desert or cold desert. If hot desert is there, that means that the air mass over there will be having temperature which is high, and we are talking about the snow covered plains or the cold desert, so the temperature will be low. Okay, coming to the oceans, so obviously oceans are having different kind of temperature. If it is in the polar region, the temperature will be low. If it is in the equatorial region, it will be having a high temperature. And obviously, since ocean is there, moisture will be there, so humidity will be high over there. Okay, now they are saying that it is forming over the large and uniform surface. Obviously, to acquire uniform temperature and the humidity conditions, so it should have the large and uniform surface or the source region. So option C would be a right answer, which is saying that both the statements are correct over here. For your understanding, I have given this diagram over here. So this is ocean. So the air mass which is above the ocean will be having the temperature depending on the temperature of the ocean. Okay, if it is cold, or let's say in the polar region, okay, so temperature will be less. If it is warm or it is in the equatorial region, temperature will be high, and moisture will be high in this particular region, considering that the ocean is having a lot of water and evaporation will be there, so moisture will be high. Coming to the desert, which we have already discussed in case of both hot as well as cold desert. So this is your hot desert, this is your cold desert. Okay, now let's move further. This explanation is given in the text form, which I have already explained to you. Now considering question number 2. 2 says that consider the following statement regarding the Coriolis force. We will be talking about that, and statement is saying that it is caused by the rotation of the earth. This is the first factor which you have to consider, which makes moving air follow a curved path instead of a straight line. Okay, these are the two things which we'll have to understand with respect to the Coriolis force. And second statement says that it is maximum at the equator and becomes zero at the poles. We will see how. First is the rotation of the earth. So let's see, this is your earth, which is spherical in nature. Okay, almost spherical, I would say. Now this is your equator. Equator is having higher diameter, or you can say diameter is maximum at equator and minimum at poles. Okay, now we know that earth moves from or rotates from west to east direction in a particular time frame. The time in which earth completes its rotation, that is same. You can tell me in the comment box that what is the time, which is a very basic question. Okay, now the rotation completes within a particular specific time from west to east direction. Now the time is same, but the thing is distance is varying. Here you can see, if we are looking at the distance which has to be covered, that is the diameter of earth, that is to be covered. Basically, when we are talking about since diameter is high, so obviously the distance which is covered during the rotation is high. Let's say if a particle is there, or let's say if I'm standing over here, so the time taken for me from, to complete a whole rotation is same, even if I'm at equator or if I'm at poles. Okay. But the thing is, the distance will be covered, the higher distance would be covered at the equator and lower distance would be covered at the pole because of the diameter. Now, obviously, since the distance is high and the time is same, so speed will vary. So we know that the speed of the rotation at the equator will be high and the speed of rotation of the Earth at the poles will be relatively lesser. Okay. Now, since the speed is high, we know that at the equator, Earth is moving with a particular speed. Now, let's say if I'm having a ball in my hand, as far as I am with the surface, I am on the surface, the ball is having the same speed as with the equator is moving, or you can say as surface is moving with a particular speed, and the ball will also have the same speed. Why? Because you know that it is in the contact with that. Okay. Now, if I leave this particular ball, as soon as I leave this particular ball would want to be in the motion. This is this basic law of motion, that body in motion want to be in the motion. Okay. Now I have left this particular ball, but I have thrown this ball in this particular direction in a straight line towards the pole. I have thrown the ball, but ball wants to be in the motion, which is the initial motion, or because of the inertia, it would want to go in the west direction. It would want to go in this particular direction from west to east. The resultant, or you can say because of these two forces, the resultant would be somewhere over here. Okay. Now you will be seeing that I have thrown the ball in the north direction towards the pole and ball wants to move in the east direction. The resultant would be something like this. Ball will start to move in a curved path and not in the straight line. Okay. So that is what all these phenomena is because of the Coriolis force. Okay. The force acting behind is the Coriolis force, or I would say that this particular force is the Coriolis force. Okay. So one thing is clear, that if I throw a ball, because of the inertia, it would want to go in a particular direction. I have thrown it in a particular direction, and because of the resultant, it will not go in the straight direction but take a curved path. Okay. So that is what statement 1 is saying. It is caused by the rotation of the Earth, which makes moving air follow a curved path instead of a straight line. Now, if it is true for a ball, it is also true for the air mass. Okay. As far as the air mass is attached with the Earth, or it is in the contact with the Earth's surface, it will be moving along with the Earth's surface from the west to east direction. As soon as it lifts itself from the Earth's surface, it will follow the Coriolis path and it will start to follow a curved path. Okay. So statement 1 is correct. It is maximum at the equator and becomes 0 at the pole. That is obvious because speed is very high over here. So deflection towards the pole will be very high. So deflection towards the poles will be very high, but deflection at the equator will be 0. Okay. Why? Because let's say here you can see one more thing I would like to add over here, that in the northern hemisphere, you will be seeing that if I'm throwing a ball towards the pole, it is moving in this particular direction, that is to right of it. Okay. So the deflection in the northern hemisphere is towards right. The same thing, the same phenomena we will be following in the southern hemisphere as well, but the deflection will be in the left direction. Okay. Now see, here deflection is in the right direction. Here deflection direction is changing. So somewhere there will be a point where the deflection will be 0. Now that point is basically your equator. At equator, the deflection is 0, that is minimum. So that is why statement 2 becomes wrong, because it is not maximum, it is minimum at the equator and maximum at the pole. So statement 2 is wrong. Option A would be a right answer, that is 1 only. Okay. Now for your understanding, I have given this diagram over here. This is your Earth and this is the direction of the rotation, that is from west to east. Here you can see the speed is maximum over here. Okay. And speed is reducing towards the pole and becoming 0 at the pole. Okay. And if we are talking about the deflection over here, you can see that this particular direction, if I throw a ball, it is moving in this direction, that is right. So in the northern hemisphere, the deflection is toward right. In the southern hemisphere, the deflection is towards left in both the instances. If you want to give it a try, try to do that. You are, let's see, if you are standing over here, throwing a ball in this particular direction, and here you will be seeing that this ball is going in this direction, that is the left, you can say deflection. So that is how it is. Now coming to the next part, that is the explanation which is given over here. We have already discussed it. So here you can say that statement 1 is correct, which we have already seen, and statement 2 is not correct, because here you can see the strength of the Coriolis force depends both on the latitude as well as the velocity of the moving object. It is maximum at the pole, where the Earth's rotation is the most effective, and becomes zero at the equator, which we have already discussed. Okay. Now deflection, if we are talking about, the winds are deflected in the right direction in the northern hemisphere and left in the southern hemisphere. That is what Coriolis force makes us understand. Okay. Now let's move to the question number 3. This pressure belt is dynamically formed by the convergence of warm westerlies and cold polar easterlies, resulting in the rising air current, frequent cyclonic disturbances, and variable weather conditions. It shifts northward in the July and southward in the January with the apparent movement of the sun. Now we know that with the sun's position, the pressure zones are created, how it moves and all. So that is the basic geography. I will not go into details of that. What they are saying is that the warm westerlies and the cold polar easterlies. Okay. So if we are talking about the cold polar easterlies, they will be, starting from somewhere over here. Since it is easterly, that means that it will be starting from the east and moving in this particular direction. And then comes this particular region. And here they are talking about the warm westerlies. Westerlies are there. They are originating from the west and moving in this direction. Okay. Now they are saying that which particular pressure belt is that. Okay. So obviously this is your polar. So they are talking about the subpolar. Okay. Second thing is, whenever we are saying that it is converging over here, whenever there is a convergence, that is the area of, you can say, low pressure. Okay. Why is that? Because here you can see a particular air mass is coming like this, a particular air mass is coming like this and converging over here, and it will start to move in the you can say vertical direction from there. That is basically the area of low pressure. Okay. So here option C would be your right answer, that is subpolar low pressure belt. Okay. Here you can see option C is your right answer. To make it understand what these high pressure and low pressure conditions are there. So let's see, if this is the area, we know that the wind or the air is moving from the high pressure towards the low pressure. Now this is your low pressure and this is your high pressure. Wind will start to move in this particular direction. So we know that if everything is moving in this direction, this is the area of convergence. Okay. The air masses will converge over here and start to go, make a movement in the vertical direction. Okay. So if they are moving in the vertical direction, the pressure at this particular point will be low. Why? Because when we are talking about the air pressure, that is nothing but the pressure which is exerted by the column of air on a particular point. Now since the air is moving in this particular direction, this is moving in the upward direction, the pressure is becoming less over here. Okay. Now if let's say you can say the direction of the movement of the air is in the downward direction, the pressure will increase. That area will be of the higher pressure. Okay. So option C is your right answer. Now to understand more, here you can see, we know that there are 7 pressure zones which are there. This is your equator. Equator is the low pressure zone. Why? Because since the highest insolation is there, since here you can see this is your equator, and sun will be having, you can say in a particular year of month, if sun is over here, this particular area will be having highest insolation, and because of which what will happen is that in a particular area, if higher insolation is there, so you know that the temperature will be high, and because of the temperature, evaporation will happen and the air will start to move in the upper, you can say in the vertical motion, and it will start to go upside in the atmosphere, and at that point of time or at that particular point of place, the pressure will start to decrease. Okay. So here you can see this is the area where insolation is high, temperature is high, and since temperature is high, evaporation will happen or the convection will happen, and because of which the area will be of a low pressure. Okay. Moving further, here this is an area of high pressure, that is your subpolar or you can say subtropical, not polar, subtropical high pressure zone, and this is your subpolar low pressure zone, and here these are the polar highs, polar high. Okay. So this is how we can say that there are 7 belts. One is this, second is this, third and fourth, fifth, sixth and seventh. Okay. Now let's move further over here. This I have kept over here for your own understanding, that pressure belts are formed by the uneven. solar heating, which I have already discussed, Earth's rotation, intense heat at the equator cause air to rise, which we have seen, that creates a low pressure, while the polar cold makes the air sink, and because of that you will be seeing that there is a high pressure, because if air is sinking, that means that it is exerting more pressure on that particular point. That is why this is the area of high pressure. And if the air is rising, so pressure is getting released, so this is the area of low pressure. Okay, now this is something which is very basic, which has been discussed in your geography, so I won't go into details of it, but for your reference, if you are going through the PPT, you will be able to revise it properly, so I have kept it over here. Now the same thing is written over here, you can go through it. Option C is the right answer, which we have already seen, subpolar low pressure belt. Now coming to the question number 4, consider the following statements regarding the easterlies or the trade winds. Here you can see in this particular diagram, you can see that when we are talking about the equator low pressure zone, here we will be seeing trade winds, and if you look at the trade winds, the origin is from the east direction, so these are called as the easterlies. Okay, here also you can see from the east direction, this is moving towards the west, or deflection is towards the west, so that is basically trade winds, which are easterlies. And if you move over here, you will be seeing that these are westerlies, because the origin is from the west. Okay, so when you are talking about the easterlies or the westerlies, that are defined by their origin, from where it is getting originated. And all these things, how it is happening over here, that why we are saying that origin is from there and deflection is toward that, that is all because of the Coriolis force, which we have already seen. If you want, you can try, like if the deflection is in the right direction or not. I told you that in the northern hemisphere, deflection is toward right. So here you can say from here, it is moving, getting deflected towards the right. Okay, and if we are talking about here, so it has to be in this direction, but this is moving in the right direction. So this is impact of the Coriolis force. Now we can see, consider the following statement regarding the easterlies or the trade winds, which we have just seen. They blow from the subtropical high pressure area towards the equatorial low pressure area. So here you can see, this is your subtropical high pressure area, this is your low pressure equatorial area, and this is moving from the east to the you can say towards equator. They blow from the subtropical high pressure area towards the equatorial low pressure area. This statement is correct. Now in the northern hemisphere, these winds blow from the southwest to northeast. They are saying that southwest to northeast, but we are saying that these are easterlies. So how can they start from the southwest? They will be starting from the eastern direction. So that is why this statement becomes incorrect. Option A would be your right answer. Okay, so option A is your right answer. I have already told you that this easterlies are easterlies because the origin is from the east, okay, and not from the west. Okay, now let's move further to the next question. Which of the following is the common effect of El Nino on the global weather patterns, heavy rainfall in India and Australia? Now if you have followed the newspaper thoroughly, or otherwise also if you have read geography, you know that El Nino has the adverse effect on monsoon. Whenever we see that the monsoon has been deficit, or there has been a deficit in the monsoon, generally one of the reason is the El Nino effect. Okay, so heavy rainfall in India, now that would not be true, because we are saying that it is having adverse impact. Strengthening the cold water upwelling near Peru. Now if we are talking about the Peru region, okay, and the cold water is coming upward, that means that the Peru is getting or becoming cold. Now that is not true, because when we are talking about the El Nino, that is from the normal, it is kind of a warmer condition in the Peruvian coast. So this statement is also incorrect. Drought in the Indonesia and weak monsoon in India. Now this statement is correct, because we know that having adverse impact on the India's monsoon. Okay, so option C would be your right answer. Here you can see option C is your right answer. Now coming to the understanding what is El Nino and what is La Nina. Okay, now in the normal year or in the normal conditions, you will be seeing that this Peruvian coast, because of the Humboldt current which is there, it is generally cold in nature. Okay, and the corresponding areas which are there in the, you can say, Western Pacific, these are generally warmer. Okay, now this is the normal condition. But if that reverses, and if this particular region or the Peruvian region becomes warm, it is cold right now, but it becomes warm over here, so this particular area will be facing you can say rains, and the area in the regions of Australia, or you can say in the Western Pacific, they will be dry. Okay, and this will start to become a little cold. Okay. Now considering that, we are saying that the total reversal is happening over here, that is El Nino year. Okay. From the normal year, it is deflecting and getting, totally reversed, that is El Nino year. But what if this normal condition, stays, but in a extreme situation, if this particular area, it is cold and it becomes colder, even colder, or you can say extreme cold is faced over here, that condition will be considered as La Nina. Now, why is that happens? So here you can see El Nino occurs when the normal circulation of the tropical Pacific Ocean and the atmosphere is disrupted. This is the normal circulation. Why it is a normal circulation? Because of the, you can say, your equatorial current, that is a motion which is there from the you can say eastern side of Pacific to the western side, and the western coast will be facing a heat, or you can say warmer conditions. That is the normal condition. Now, if this cycle disrupted, so this particular area will not be as warm, and this particular area will not be cold, and it will start to get warm, and that is the condition which is called as the El Nino. Okay. Coming to the La Nina part, it occurs when the normal Walker circulation, this whole circulation is called as the Walker circulation of the Pacific Ocean, becomes supercharged. Now, this is the normal condition, but what if this current becomes even more stronger? So this particular area will face higher temperatures. This area will face even lower temperatures, and that is why this is called as La Nina. Okay, I hope that is clear. Now we can move further to the next part. Now, this whole cycle, this whole oscillation in the Pacific region, in between the eastern and the western Pacific region, that is called as the El Nino southern oscillation. Now, in the southern oscillation, we can see that there is also a temperature change which is happening, which we have seen, and there is also pressure change. We can say that the oscillation is between the temperature and the pressure, and that is called as El Nino southern oscillation. Generally, it is happening in the southern hemisphere. Okay. Now let's move further. Option C is your right answer, which we have already discussed over here. Okay. Now let's move further to the next question. Consider the following statement regarding La Nina, which we have already discussed. Let's see. It occurs when usually strong trade winds cause an abnormal accumulation of the cold water in the central and the eastern Pacific Ocean. Here you can see this is your western Pacific, this is your eastern Pacific. When I told you that in La Nina, this will be the extreme condition. So this particular area will be extremely cold. So this is the eastern Pacific Ocean which is getting cold. Okay. So here it occurs when the unusually strong trade winds cause abnormal accumulation of the cold water in the central and the eastern Pacific Ocean. This is correct. Now, La Nina conditions are associated with the colder than normal winters in North America and enhance the hurricane activity in the Atlantic Ocean. Now, if you look at the statement, you will be confused that is what is happening in the Peruvian coast, that is Southern America. Why they are talking about North America? Now, one more associated phenomena is that is jet stream. Jet stream. Now, what are jet streams? These are the upper air circulations which are there, and they are getting impacted by the, you can say, surface conditions as well. Now, in the La Nina conditions, what happens over here is that here you can see in the southern part here, we have seen that there will be a condition that is kind of cold in nature. Okay. If it is a cold in nature, somewhere over here will be there will be a generation of high pressure in the North American region also. Now, this jet stream is there, that is getting affected, that moves in the northern direction. And since this jet stream is moving in the northern direction, then there are high pressure conditions which are getting generated over here. This area becomes cool. Since this particular area becomes cool, warmer conditions becomes over here. Low pressure is generated in the Atlantic Ocean, and because of which you will be seeing that there are hurricane activities which are more in the Atlantic Ocean. Here you can see fewer hurricanes will be seen over here, and higher hurricanes will be seen in the Atlantic Ocean region, because that is low pressure conditions are getting you can say generated over here. Okay. So option the statement 2 is also correct. La Nina conditions are associated with the colder than normal winters in Northern America because of the jet stream, and not because of the current or you can say the exactly because of the situations which are there in the Southern America, and enhanced hurricane activities in the Atlantic Ocean. Why is that? Because I told you that there will be a low pressure situation which will be generated over here. Winds will start to move from this direction to this direction. This particular region, they will get the moisture, and low pressure conditions will be happening over there, and hurricanes will start to happen over there. So statement 2 is also correct, 1 is also correct. Option C is your right answer over here. Okay, you can go through this particular explanation over here. What I told you about the jet streams and the Atlantic Ocean and hurricanes, that is given in these two statements, which you can go through, or I'll do it for you. The altered circulation during the La Nina leads to the colder than normal winters across the North America, particularly in Canada and the northwestern United States, due to the shift in the jet stream. Okay, it also enhances the hurricane activity in the Atlantic Ocean, as cooler Pacific conditions reduces the wind shear that normally suppresses the storm formation in that particular region. You don't have to go into much details of that, but you will have to understand that in the Northern America also, on the, you can say, western coast over here, you will be seeing that there are colder conditions which are getting generated. Okay, now let's move further to the question number 7. Consider the following statement regarding the Indian Ocean Dipole, that is IOD. Now, Indian Ocean, like the Enzo circulations which are there in the Pacific, even in the Indian Ocean, there are some kind of oscillations which are happening. Okay, so these are called as the Indian Ocean Dipole. Now, this is your Indian Ocean. One part is here, which is your African Horn, this particular part, and second part is over here, that is basically your Malay Peninsula, etc. So, if this particular part get or you can say generate low pressure area, okay, because of the low pressure area, you know that there will be you can say evaporation, there will be convection, and these you can say winds which are getting which are basically getting convected through this particular region, they will start to move in this direction during the monsoon, because we know that we are having a southwest monsoon, so it will add up to the monsoon. Okay, now this condition will be called as the positive IOD. Positive IOD because it is adding up to the monsoon and it is moving into India and it is benefiting the monsoon. If the you can say conditions get reversed, if the high pressure zone is created over here, low pressure zone is created over here, and because of which what will happen is that this will not support the monsoon, it will adversely impact the monsoon. Okay, so let's see what is happening over here. During a positive IOD, the Western Indian Ocean near Africa becomes warmer, while the Eastern Indian Ocean near Indonesia turns cooler. This is true, which we have just seen. During a negative IOD, the Eastern Indian Ocean, that is getting warm, and the enhances the frequency of cyclones in the Arabian Sea. Now they are saying that the Eastern Indian Ocean, okay, so they are saying that this particular area is getting warm, this particular area is having a low pressure, getting warm. So obviously the circulation in the, or you can say the activities, rainfall, etc., which will be higher in this particular region and not in the Arabian Sea. This will be more in the area of the Bay of Bengal, okay, and but not in the Arabian Sea. So this statement becomes incorrect. Okay, option A would be your right answer. For your understanding, here you can see this is the neutral condition, normal condition, when there is no high pressure or low pressure is getting created. Now if you look at this particular region, in the negative you can say IOD region, here you can see this particular when we are talking about the region, this is the area where chance of rain is getting enhanced. Why? Because this is India. Okay, this is your area where you can see the high pressure is generated because it is a negative you can say cycle, and this area is generating low pressure. Low pressure area is there, convection will be there, evaporation will be there, and you will be seeing that there will be rainfall which is happening over here. Okay, and if you look at this particular cycle, that is your positive IOD. In the positive IOD, you will be seeing that the African region will be having a low pressure zone, because of which convection will happen and rainfall activity will enhance in this direction, and these winds which are having moisture which start to move in the start to get inside India as well because of the southwest monsoon, and it will add to the monsoon. Okay, so that is why it is a positive IOD. This region will be having high pressure, and that is why the rainfall will be reduced over here. So here you can see statement 1 is your right answer, that is during a positive IOD, the Western Indian Ocean near Africa becomes warmer, and that is why more rainfall will happen in India. Moving further, question number 8, consider the following statement regarding the extratropical cyclone. We have seen that cyclones are kind of, in the geography you must have read that cyclones are, one is your tropical cyclone, then there are temperate cyclones or the extratropical cyclones which are called as the temperate cyclones. Okay, now regarding that we'll have to understand these two statements. They develop along the polar front where warm tropical air masses meet the cold polar air masses. Now when we are talking about the tropical cyclones, now tropical cyclones are generating on the oceans because of the change in the pressure conditions. Okay, because of the change in the pressure condition. If there is a low pressure condition, since we are talking about the tropical cyclones and they are on the equatorial area or the tropical regions, obviously they will have low pressure regions and then they will be generated in the tropical regions. Now when we are talking about the extra tropical, these are not getting generated because of the you can say presence of the ocean or because of the presence of the low pressure. These are then getting generated because of the front generation. Okay, there is this phenomena, fronts. That front is basically where two different air masses are interacting with each other. Let's say this is a hot, or you can say warm air mass, and then there is a cold air mass. If they are interacting with each other, that is called as the front generation. And when we talk about the front generation, this will give a condition where extratropical cyclone will get generated. Okay, so here you can say they develop along the polar fronts where the warm tropical air masses are meeting with the cold air masses. Okay, coming to the next one, these cyclones are formed mainly due to the convergence of the winds in the low pressure zones within the tropical latitudes. Now they are saying that within the tropical latitudes. Why would that be an extra tropical cyclone if it is getting generated in a tropical latitude? If it is generated in the tropical latitude, it is a tropical cyclone. Okay, so statement 2 is incorrect, 1 is correct. Option A is your right answer. So here this is the you can say generation of the extra tropical cyclone. Here you can see there is one cold front. Okay, this is the warm air mass, this is the warm front. Okay, so here you can see if the cold front is there, warm air mass is there, warm air mass will start to rise, there will be a cloud formation, then there will be a rainfall. Second, here you can see also that if there are warm air mass is there, the cold air mass is there, obviously we know that warm air mass is basically light in nature, this will start to rise over the cold one, and again cloud formation will be there. Now when we are talking about the direction of it, that direction will be controlled by the direction of these fronts over there. So that is how that you can say a curve, or you can say a rotational motion is getting generated, and because of which the cyclone is getting generated over here. Okay, so here you can see the extratropical cyclones are known as the temperate or mid latitude cyclones, are not tropical cyclones, are large low pressure systems. Pressure system is also low over here, but the reason behind the generation is not the pressure, it is generally because of the front generation. Okay, that developed in the mid and high latitudes between the 30s and 60 degrees north and south. Unlike tropical cyclones, which derive their energy from the warm oceanic convections, extratropical cyclones generally are formed due to the horizontal temperature and the pressure contrast. That contrast is basically because of the front generation. Okay, so that is there. Now these cyclones develop along the polar front, which we have already seen, where the cold and the hot air masses are getting you can say interacting with each other. So that is about the you can say extratropical cyclones. Now for your understanding, I have given the journey of a tropical cyclone as well. Here you can say low pressure area will be there because of the equatorial condition, temperature is high. If temperature is more than 27 degrees Celsius, so here you can see there will be you can say upward movement of the hot air and the cloud formation will be there. This is about the tropical cyclone. Now let's move further to the next question. Consider the following statement regarding the inversion of the temperature. Now the term inversion, that means that if we are talking about a particular phenomena and that is getting reversed, that is inversion. So they are talking about that it occurs when the normal lapse rate is reversed. Okay, what is lapse rate? Lapse rate is basically change in temperature with altitude. Okay, generally you must have felt that if you are moving on a mountain, okay, temperature will be little bit higher over here, but as soon as your height is increasing, or you can say as your height is getting increases or the altitude is getting increases, you will be feeling that there is temperature, or you can say low temperatures are there. So generally you will be seeing in the mountainous regions or the hilly regions, you will be feeling little cold because the temperature is getting lower. So there is one phenomena, that is with your height, as the height increases, temperature will start to get decreasing. Okay, so that is called as the lapse rate. Now inversion of temperature is that when this phenomena is getting reversed. Okay, so it occurs when the normal lapse rate is reversed and the air near the surface becomes warmer than the air above it. Okay, so here you can see this is the surface. Okay, and if we are talking about normal lapse rate, height is increasing, temperature is decreasing. Okay, now they are saying that it occurs when the normal lapse rate is reversed and the air near the surface becomes warmer. Air near the surface becomes warmer than the air above it. So that is normal condition. Okay, considering the next statement, it is the most common during the long winter nights with clear skies and the calm conditions. Now they are saying that lapse rate is getting inversion, because we are talking about the inversion over here. This is the normal condition. If you are at a lower height, obviously this will be having a higher temperature, and if you are at the altitude, temperature will be lower. But they are saying that near the earth surface, warmer conditions are there. That is the normal condition. So no inversion is happening over here. So that is not the definition of inversion. What would have happened over here, that if the temperature is lower near the surface and the above temperature over here is higher, that is basically inversion, because in normal condition the temperature at the height will be low. Okay, again I'm repeating it again for you. In the normal condition, what will happen is that this is your earth surface, and if you are moving in the higher altitudes, okay, so height is getting increased, so temperature will be reducing. Okay, so temperature here will be high, temperature here will be low. Now that is, the statement is saying that the temperature near the earth surface is high. So this is the normal condition. Temperature near the earth surface is supposed to be high, but if it is reversed, then it is the temperature inversion. But in this statement, this is not talking about the inversion over here. So statement 1 becomes incorrect. Statement 2 is saying that this is most common during the long winter nights with the clear skies. We will be seeing how. Statement 2 is correct over here. Option B is your right answer. Now here you can see, this is the normal condition where you have a lapse rate. Temperature over here is higher, temperature over here is getting lower. With the height, temperature is getting lowered. Now in the inversion condition, what will happen is that the temperature here will become lower and temperature here is high, and moving further the temperature becoming lower. Okay, why is this temperature low? Because in the nights you will be seeing that the earth start to radiate its energy, okay, and the temperature or earth starts to cool in the nights. Okay, now since earth is getting cooled, it will have an impact on the air mass which is attached with the surface, and because of which, if earth is getting cool, the air mass will also start to get cool. But over here, the just above the surface, there will be a air mass which is basically hot in nature. Because of the loss of the radiation, you will be seeing that the temperature is getting reversed over here. But the normal phenomena, if we see, there is the hot air which is there, and because of which this particular region will be having a lower temperature. This temperature will be high, which is inversion of the temperature. In the normal condition, it would not have happened, but in the winter nights, it is more common, because earth will have more, you can say, earth will have a lesser radiations in the, you can say, lesser temperature in the winter nights. Okay, so again I would say that if the earth is losing its radiations, and you will be seeing that the temperature is reducing near the earth, and above that it is having a higher temperature. Now normally what happens is that with the height, temperature becomes low, but in this condition the temperature here is low, but here the temperature is high, and that is why it is called as the inversion of temperature, where the normal lapse rate is, the phenomena of normal lapse rate is not getting followed. That is your inversion of the temperature. It is happening during the winter nights, because obviously during the winter nights there are high chances over here that temperature will be low, and you have seen that in the foggy situations will be there, frost etc. Getting generated during this particular winter nights, and skies are clear and calm air conditions are there, because of which this air is not getting dispersed, and that is why this temperature inversion happens over here. Now here you can say in the normal condition what happens is that here you can see the temperature is getting lowered during the normal time. Here warm air is there, then there will be a cooler air, and then there is a cold air. Okay, now here in the temperature inversion, what happens is that here you are supposed to have temperature which is high, but because of the smog or because of certain situations when air is or you can say earth is losing the radiations and the temperature becomes lower over here, but a warm air mass is present over there above it. That is why we are supposed to have a higher temperature over here, temperature which is lower over here, and the lapse rate phenomena is not working in this particular case. That is why it is called as the temperature inversion. Okay, the explanation is given over here. You can go through this. Now question number 10, it is a warm, dry and gusty wind that descends along the leeward slopes of the mountains often causing a sudden rise in the temperature by 15 degree to 30 degree within an hour. It occurs mainly in the Alps region and is known for the melting snow rapidly and bringing clear weather conditions after the onset. So basically they are talking about a particular slopes of the mountains. So this particular condition, you must have seen that there are valley breezes. Okay, so these valley breezes or local wind phenomena is quite prominent in this particular area. Okay, so it is a warm, dry and gusty wind. If you look at the names which are given over here, Chinook, Fohn, Sirocco and Lu, these all of them are warm local winds. Okay, then comes the next one, that where the wind that descends along the leeward slopes of the mountain, often causing a sudden rise in the temperature by 15 to 30 degrees Celsius. It occurs mainly in the Alps region. Now you must know that Alps are the mountains which are somewhere over here. Okay, so this is about the Alps region. Then it is known for the melting the snow rapidly and bringing the clear weather conditions after its onset. Okay, now if we are talking about the local winds, I'll tell you that what kind of local winds are there. So if you look at this particular area where Alps are situated, here Fohn is there. Okay, so obviously option B would be a right answer over here. Other than that, you can go through this particular diagram over here. If you look at the Chinook, Chinook is there in the you can say North American continent. Okay, west coast of the North America. So that is there. This is northern, you must have heard about it. And Sirocco, if you see, Sirocco is located over here in the African region. From Saharan region it will start. So that is there. Okay, this is your Berg. Lu, you must have heard in the Indian subcontinent. We have Lu as a local wind. Sirocco we have already discussed, Chinook we have discussed, Lu we have discussed, and Fohn is your right direction because that is the only wind which is found in the Alps region. Okay, so this is about it. And here I have given this diagram of adiabatic and the katabatic winds, which are basically a reason behind the local winds. You can go through this, and here you can see local winds are the small scale winds that develop in the specific region due to the variations in the temperature, pressure, topography, etc. These winds influence local weather, temperature and the humidity patterns, and they may be either hot like Lu, Fohn, Chinook and Sirocco, which we have seen that all of them are hot winds, and Bora and Mistrals. And here you can see the Fohn is the warm and dry wind which we have seen, and that is generating around the Alps region, which we have already seen. Now if we talk about the Chinook, this is also a warm you can say wind, local wind which is there, and this is generally in the Rockies in the North American region. Then Sirocco, which we have already talked about, in the Saharan region, Sahara Desert, and Lu, which is generally in the northern India and the Pakistan region during the May and June. Okay, so I hope that is clear. Now in the end there is a practice question for you. Submarine canyon are most commonly found along which of the following? A, coast having faulted scarps and numerous islands. Indented coast with shallow slopes. Straight coast of the continental margins. Polar coast with the extensive ice shelves. Okay, so you can attempt this question and answer to me in the comment box. With that, I would like to take your leave. I'll see you in the next episode. Till then, have a nice day. Thank you, and please don't forget to subscribe the channel. Thank you.
For more informative content, like, share and subscribe, and do not forget to press the bell icon to get the notifications.